Hi Utpal, hi Alok. Can you hear me?
Yes, sir.
Okay.
Yes, sir.
Hi everyone. We'll give a couple of minutes more for people to join. Okay. We'll start now. Hi everyone. Good afternoon. How are all of you doing? I guess I hope I'm audible.
Yes, we are fine.
Okay. Okay. So we'll start today's class. I see people are joining. But meanwhile, let me start sharing my screen. Let me know if you are able to see my screen. Are you able to see the presentation?
Yes, sir.
Okay. Um, so, so I guess this is an elective for all of you, or this is a compulsory course.
It's an elective.
Okay. Okay. So we will have around 30 lectures in this course, and some of the lectures we'll do online. So I am located in Bangalore, so I'll be traveling. Maybe I'll be traveling to campus maybe once a month, and that time we'll do few classes in your campus, and the rest of the classes we will do online. So we will have some assignments and quizzes, I mean assignments and case studies as part of this course, and that I'll try to do those in person because it's easier to discuss in person. And some of those assignments will be take home assignments where you will get maybe a couple of weeks to solve the assignments. Okay, so let me first give you an introduction of myself. So my name is Abhik. I am actually a working professional. I work as a principal OR scientist, operations research scientist at Western Digital. If you have not heard about Western Digital, then SanDisk in Bangalore. And before this, I was working with other organizations like Bayer, Intel, FICO, and so on. And I have around 14 years experience now in advanced analytics, primarily in operations research, mathematical optimization, and a few years of experience in data science and machine learning. And I have worked in different industries like manufacturing, supply chain, logistics, pharma, media, telecom, and last year also we had the same course, not exactly the same course, but it was a 2 month course in March and April. It was a 2 credit course, and it was quite appreciated by the students who are enrolled for the course. So this year it's a 4 credit course, that is 30 lectures. And apart from your institute, I've been doing a lot of collaborations, workshops, and lectures in different other premier institutes of the country. Um, so okay, I'll skip this. So this is the tentative lecture plan for the month of January. So we will have the lectures at the same time, that is 3:30 to 4:45 p.m. on Saturdays and Mondays, and all of these classes will be online. And after that, maybe towards the end of the month, I'll try to be in your campus for 1 and a half days, where we'll have few in-person classes. Okay.
So,
And
sir, most of the course will be online.
yeah, so I'm actually located in Bangalore, so it's difficult to travel every frequently. So I'll but what maybe you can say 50% of the classes will be online and 50% will be in person. So the days I'll be in at CMI, though in those days I'll try to have more. I'll try to squeeze in more classes so that we can cover more content. Maybe we can have like 3 classes in 2 days, something like that, or 4 classes in 2 days. Like it will typically be in the. I'll try to travel on a maybe on a Friday and Saturday we can have few classes. Saturday 2 classes and maybe Friday 1 or 2 classes.
ঢুকতে বললি নাকি দেখা পাবো না 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 আমি এখন এখানেই থাকবো ওই অনলাইন কোর্স আমার এখন পুরোটাই দিল্লি বলেছিলি তো দিল্লি না তো চেন্নাই আসতে পারবো না 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 আমি আছি এখন তুলবা না যে নাটকে ঢুকে জয়েন করবো বুঝে টাকাটা ফোন করবো একটু ব্যাক টু
Okay,
দ্য
okay. Can you mute
মাই
yourself? Okay, so does it answer your question?
Yes, sir.
Okay. Okay. Yeah, and in terms of evaluation components, what I've thought of is something like this, that you will have a midsem exam, I guess, for everyone in the first week of March. So that will have a 20% weightage. So that will probably be maybe a 3-hour test where I'll give some formulation exercise, which you can do in 3 hours, which you can complete in 3 hours, and that will be less complex. I mean, less difficult, and there will be maybe like 4 take-home assignments with 15 percentage weightage for each of them, and these will all be this will be, of course, increasing difficulty. So maybe the first assignment will be a little easier, and the second, as we move forward, the next assignments will be more complex, and these will all be and you will get probably like 2 weeks to solve the assignment, and after at the end of 2 weeks, we can, after all of you have submitted your assignments, you can we can discuss all the solutions that you have submitted, and there might be some things which are wrong, so we will discuss those aspects, and each will try to spread out these take home assignments over the entire course of 4 months. And in the month of May, when your end sem exam happens, that time we'll have another another quiz or online test. Again, that will be also be formulation based. So that will be having 20% weightage, and this will again be of probably of 3 hours. So those are the evaluation components I have in mind. And in terms of the features of the course, so this will be a very interactive course. It will not be a one-way lecture by me. I'll encourage you to ask as many questions as you can, and don't wait for the lecture to end, the 1 hour 15 minutes to end, to ask all your questions. You can always stop me in the middle and ask questions, or if you want me to explain something another time, you can do that. And in this course, we will not go into too much of theory or too much of abstract maths or mathematical algorithms, but it will be more application oriented. So we will focus on some real life problems, and some of these will not be the typical problems that we solve in the books, that you find in the textbook, where you have two products and or whatever, two machines, and you have to solve the problem. It will be very real life. It will be very practical problems, and I am hoping that if you solve these problems, it will give you a very good idea about how you can solve OR problems in the real world. And if any of you is interested in pursuing a career later on in OR, then this course will be very helpful for you. And also we'll cover some key concepts which are typically not covered in academia. Example, constraint programming. So the topics that we'll be, or the concepts that we'll be covering in this course are, again, I've not listed all of them here, but these are broadly the topics or concepts we'll be covering in this course. So one is formulation and linearization tricks and techniques. How solvers work. So there are different mathematical or optimization solvers which are used to solve OR problems, real life OR problems. So we'll see how those work in the background. Some tricks and tips for efficient formulation. First of all, we'll see how to formulate. That is the first thing, and after that, we'll see how we can formulate a problem efficiently. And once you get the optimization output, how do you validate that it is good? And then we'll have some brainstorming sessions or case studies or assignments, as we discussed, and there will be some coding sessions. So you don't need to really be a very good programmer or something like that, but we'll see some of the basic rules or basic rules that you should follow while coding in the sense, when after you build the mathematical model, we need to write that in a program. So how do you do that efficiently? Determining the optimal hardware that is required for solving OR problems. So OR problems are very memory intensive. So how do you decide how much hardware your computer should have? And this is another thing, how optimization is used in reinforcement learning. And we will focus in this uh, course, we'll focus mainly on the techniques which are used more of frequently in the industry, that is linear programming and mixed integer linear programming. We'll not go too much into nonlinear programming or stochastic optimization or constraint programming, but we'll have some classes for this, so that I can introduce you the basics of these things. And then we'll also look at queuing theory or discrete event simulation, and how it is used in the real world. And apart from that, we'll also look at some applications of OR in different industries, like logistics, vehicle routing, then in airlines, banking, and those things. Okay. Any questions so
Sir,
far? Yeah. Mhm.
yes, sir. Sir, what kind of language will we be using?
Yeah, so there are two aspects. So in terms of programming language, we can use any language. So you can use Python, for example. We can you can write the code in Python also,
Okay,
or you
sir.
can use C Sharp, C++, Java, anything. And
Okay, sir.
again, yeah. Okay.
And sir, is there any other book that you recommend for this course?
Yeah, there are some books. Yes, probably I'm gonna put a slide for that. I'll send you that list, and most of the contents that I'll be covering in this lecture, yes, not lecture, but in this course will be. You'll not find that in any books. It's based on my industry experience. So there is no book as such. But yeah, there are some good. Uh, yeah, there are some good books. I'll probably send you that list. I'll probably put that in the next class. I'll
Thanks a
give
lot.
share that slide. Yeah.
Sir, I didn't get the mid-sem, end-sem part. Will it be in the form of online quiz, something like that?
Yeah, the mid-sem end-sem part will be in the form of online quiz. When I say quiz, it will be like a mathematical problem. Like you'll be asked to formulate a problem, and it will be there will be a problem statement, and you need to come up with a mathematical formulation. So I think last time what we did is I forgot now, but there'll be a timer. It will be like a 3 hour timer, and within that time, 3 hours, you can either write the solution write the formulation in a Word document and upload it, or you can write it on paper and then you can take a picture and you can upload it. So both are anything is fine. That's the format.
Okay, sir, got it. Thank you.
Yeah. And of course, I'll give you something which you can do, which you can complete in 3 hours. And take home assignments. So last time there was some request that some of the take home assignment, one of the take home assignments was a bit complex, which was difficult to finish in 1 week. So some of the students requested that they would solve in groups. So that is also, so some of these take home assignments which are more complex, or for which we don't have much time, we can do that in you can do that in groups also, so that we can discuss as we approach the assignments. Okay. Any other questions?
Also, sir, what are the prerequisites for this course?
What are the requisites? Yeah, so requisites are, you should have some very very basic understanding of linear algebra. I think all of you would have that, right? I'm assuming. I mean, there is no
Yes,
basic.
sir.
There is apart from that, there is no basic requisite as such, because whatever we do in optimization is very. I mean, it's applied math, so it's not some rocket science. So you can always learn that in the course. But yeah, I mean, as long as you are interested in maths, and I think all of you are interested in maths. That's why you have enrolled for this particular degree. So you should be good. Okay. Yeah. Any other question? Okay, so I had some questions for you before I start with the main lecture. Let me see if there's anything. Okay. Yeah. So one is I would need one of you to volunteer as maybe a student representative or whatever you call it. so that if there is any communication or if there is something I need to ask in terms of your the available time of all of you when we can have a class, so that would be easier. So if any of you can volunteer as a representative, and you can discuss and let me know. The second aspect is in terms of your availability for online. Sorry, not online, but the physical class. I hope you're still able to see my screen.
Yes, sir.
Okay, so I think this is the the timetable that you have, right, for this semester. Right, these are the courses that all of you have, right?
No, sir. Actually, some of us are from BSc, so we have various electives as well. So, like, it's very mixed up, I think.
Okay. No, I mean, I basically wanted to figure out a time, day rather, day of the week, which is so Saturdays. I think all of you are, available, right? Available for the, the in-person class.
Yeah, I think so, sir. Yes.
Okay. And among the other days, maybe like Friday, second half, most of you are available.
Friday, I just have a class at 5.
Sorry.
I have a class at 5.
Okay. Okay. How about the same time, 3:30 to 4:45? All of you are free. Or I think last time what we did is no, okay, 3:30 to 4:45 or 2 to 3:15. This is uh, these are available for all of you, or is
Yes,
it
sir. Friday also 3:30 works.
okay? Okay, good. So Friday 3:30 works for everyone.
Works about the recognition of teacher UG.
I'm sorry. Can you repeat? Sorry, I didn't get. So Friday 3:30 works for everyone.
Yes, sir. For masters in data science, it works.
Okay. 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 Yeah, I think so. Probably when we can have in-person classes that time. Okay. And how about Monday? And so generally, which out of the 5 days of the week, which days you have these classes, least number of classes? Is it Friday?
Yeah, sir. So for me, like I think I'm the only one who is from BSc here.
Mm-hmm.
So I think for me, the current timing works, and also Friday 3:30 is fine totally for me.
Okay. 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 Um, okay. Fine. So then probably when I'll think about my schedule of traveling, and then probably we'll do the same thing, that is Friday 3:30 and Saturday couple of classes. Okay, so now going back to the presentation, let me know, are you able to see the presentation now?
Yes, sir.
Okay. Okay, so today's lecture and probably the next lecture, what we'll do is we'll go through some very basics of optimization. For that is, what is optimization? And first of all, do you any of you have any background in, or do you already have any prior knowledge, or did you already cover any course in OR earlier, or in your undergrad, for master students in your undergraduate degree? Did you have any course on operations research? Any of you?
Yes, I had a course on optimization in my undergrad. It was more of a theoretical course. It's not
Hmm.
coding and such.
Okay, okay, no problem. Okay, so we'll go through what is optimization, how it originated, where it is used, and why it is used. and the business impact of optimization projects, size and complexity of optimization problems. Size and complexity meaning, in academia, the problems that you solve, sorry, not solve, but that you see are very small in size, maybe 2, 3 variables, but in real world problems can have 2 million or 2 billion variables also. I mean, millions and billions of variables also. We will see how OR is used in different industries. So just for clarification, the terms of mathematical optimization, mathematical modeling, these are all used, optimization, these are all used interchangeably, so they are all equivalent. But when we say operations research, and even sometimes I've written optimization, sometimes I've written operations research, so you might be wondering whether they are same or different. So actually, operations research consists of different topics, like one is optimization, one is simulation, which is basically an application of queuing theory. The other is reliability, and the fourth one is probably inventory management. So optimization is a subset of operations research. But in this lectures, you'll see sometimes I've written OR and optimization. They are in the context of this lecture, they are equivalent. We'll look at the stages in optimization project, who are the stakeholders, and how important is programming. And we'll look at some of the career opportunities or career options in the field of OR. So some disclaimers, not just for this lecture, but for all the lectures going forward. That okay. So what I'll do is after, and I'm sure I am sure all of you have access to Moodle. So after every lecture, or maybe after every 2 lectures, I'll upload the presentation and also the recording. I think this meeting is getting recorded. So once that recording is available, I'll upload that, so that if any of you has missed the class or you want to view something again, then you can always go back to the recording. And I'll also upload this presentation or the future presentation, so that you can use that for your reference. But please do not share those presentations externally. It's only for your understanding and your knowledge. And the views expressed in this presentation are purely my opinions and thoughts, and does not reflect my organization views. And there will be some case studies which are not specific to any organization, but they represent some of the general problems solved in the industry. And there is some organization-specific business impact provided in this presentation, which is available in the public domain.
Sir, I just wanted to confirm, is there a Moodle page for the course?
Yeah, there is a Moodle page. Let me. I think you are able to. I sent a message on Moodle that the class will be from the link for this class rather. So did you get that message?
Yes, sir, I got it. Yes. Okay.
Yeah. So in the same, I don't know. For me, I can see in the same course I can upload all the contents. And later on, when I'll give you the assignments for solving, that time, I mean, of course, assignments, the problems we'll discuss in class, but then I'll write it down in a Word document and share. So that will also be uploaded in Moodle. And then I forgot now. I think the submissions that you do, that would also be done in Moodle.
Yes, sir.
Okay. Any other question? Okay, so these are some of the questions that we will be solving as part of this course. So maybe some of you are not aware that there like, for example, when I was a student, I did not know that. I thought that, I think one of you just mentioned that you have studied a course, you have already taken a course on OR, but that was very theoretical. And even I had that. I did not know. When I was in school, I did not know that OR I thought it's just another maths course. So I didn't know that there are some applications. So there are a lot of job opportunities in OR. So we'll discuss that. And we'll see how big and complex are real life OR problems. And I hope this course will encourage some of you to pursue a career in OR. Okay, so coming to a quick introduction of optimization. So optimization is a field in applied mathematics. So optimization comes from the word optimal, which means best. So when we optimize something, we are making it the best. And optimization started as took off during World War II. So during World War II, different countries were trying to find the best way to optimize the resources they had, and that's when they came up with this concept of optimization. And the word operations research is actually means research on operations, and operations in this case is war. So what do we do in optimization? We analyze decision problems, we formulate mathematical models, we come up with the best possible solutions, and then we test the solution for different what if scenarios. So optimization started as a field during, informally started as a field during World War II, and then gradually in the 1950s and 60s, different universities in the West started introducing operations research or optimization as one of their courses. And then scientists came up with different algorithms to solve problems, and that's how and then different solvers started emerging, and that's how the field has grown. So what do we do in optimization? We have there would be some known and unknown variable values. So known are variable values which are discovered by descriptive and diagnostic analytics, and unknown are variable values which are forecasted by predictive analytics, and there will be some business rules. So these would all go in the form of the business rules would go in the form of constraints, and the known and unknown values would go in the form of parameters. And there would be some objectives that we need to solve, and these objectives could be multiple objectives. And once we have the objectives and the parameters and the constraints, then we try to optimize. That is, we try to find the best solution that is the best values of the variables which can maximize the objective while honoring the or respecting the constraints. So this is what a typical optimization model looks like. There would be a objective function which would be either a maximization or minimization. So I should not say either a maximization or minimization. It could be a combination of both. So in this example, I have demonstrated only one objective, but there could be multiple objectives. And in this formulation, VP is the VPR is the other known values, and XP are the values of other variables. So in the while solving this problem, we try to find the optimal values of XP. And this XP variables would be subject would be restricted by certain constraints. These are the constraints that we have. That is what the constraint that you see here. So AXP and CS is something that you already know. That is, these are defined parameters. You know those values for solving the problem, and XP is what you try to find out through the model. And XP is in optimization model. The variables are always assumed to be non-negative, so they can either be 0 or greater than 0. So in this example, we have shown only one constraint, but there could be multiple constraints. And in real world problem, there would be thousands or millions of constraints. And these constraints would be typically constraints on different resource or different capacities. It could be constraint on capacity, availability, etc. And the constraints could be of the form, so in this case it is less than equal to, but apart from that it could also be of the form greater than equal to or equal to. Yeah, I think that's about this slide. So this is the basic structure of an optimization problem. So any questions around this slide? Okay. So now we'll see why we need to optimize, why we need to use optimization. So first, let's look at this example. So in this slide, in this picture, what we are showing is there is a warehouse. So let's say Amazon has a warehouse and it needs to send, for simplicity, we have taken only 3 customers. So let's say there are three customers, A, B, and C, and the numbers on the top of, and these are so the nodes are A, B, C. So they represent three customers, and the arcs connecting the nodes and the warehouses represent the distance between the warehouse and the customer, or between two customers. So the problem is to find out the best route. And let's imagine there is only one, Amazon has only one delivery executive who needs to travel to all these three customers. Now, the problem is to find the best possible route which can cover all the customers with the least possible distance. So from warehouse, you can start from the warehouse and then go to A, then C, then B, then back to the warehouse, or you can go to C, B, A, back to the warehouse, and so on. So since there are three customers, you can have factorial 3, that is 6 possible combinations. So in this table, we have enlisted the 6 possible routes and the total distance for these each of these routes. So if I look at route number 1, which is warehouse to A to B to C to back to warehouse, then the total distance would be 60 plus 80 plus 35 plus 70, which is 245. Similarly, we can manually compute the distance for all these routes, and we can easily see that route 1 and 6 is the gives the least distance. So for three customers, it's very easy. So you can even write a program which will compute the distance for all these routes and find out the minimum. Now, if you expand, if you go from extend from 3 customers to 10 customers, you will have 3.6 million possible routes, right? So instead of 6 rows in this table, you will have 3.6 million rows. And even with today's super fast computers, which can compute the distance for each route in maybe 0.01 millisecond, it might take I don't know, hours to find the least possible route. So but using optimization, you can do it much faster. And if you go beyond 10 to 13 or 20 even to 13 or 20 customers, it will take you centuries to find the shortest route manually, which is not feasible, right? So that is why we need to use optimization, because using optimization, you can find out the best solution much faster, and you'll of course get a much better solution than you will get manually. So that is the reason why optimization is used to solve these kind of problems. So this kind of problem is referred to as vehicle routing problem in the industry, and in the following lecture, we'll go through in details of vehicle routing problem. So in this case, in this problem, what is the objective function? It is we are minimizing the distance. Similarly, there could be other objectives in other problems. There could be other objectives like minimizing cost, minimizing time, number of vehicles, and so on. And if it is maximizing, it could be maximizing profit or revenue or throughput or utilization. And as you can see here, in this case, we are able to evaluate millions of possible combinations. So that is the reason why we use optimization. It would not be possible to arrive at the best solution manually. And optimization is used whenever there are scarce resources. Now, so these are some of the resources which could be scarce in different problems. So one is it could be capital or money, manpower, these people, equipment or machines, facilities, vehicles, raw materials, and time. So whenever there is a crunch of a resource, we need to find a solution which will optimally distribute these scarce resources. Then we need to use optimization. Okay. Any questions on this small problem? Okay,
Sir, can you go over how do you calculate the distance?
sure.
Like for ABC, you should just take 60 plus 80 plus 35, right?
Plus 70. You need to go back
T
to the
to
warehouse.
return.
Yeah.
Okay, okay.
Okay. Any other question? Okay. Okay, so now I think since most of your data science students, you have other courses on on statistical modeling, predictive analytics. So this slide will tell you how these different how machine learning and OR, and what is the connection, or what is how does it fall in the where does it fall in the pyramid. So this in this graph, as you if you see from x to on the x-axis, it is the difficulty level increases from the left to right, and from bottom to top, the value increases. So the most fundamental analysis that you can, so given any data, the most fundamental analysis that you can do is descriptive analytics. That is, you can, so for example, you can look at historical sales data. Let's say I provide you some sales data, and you can find out from the data what was the maximum sales, or in which state the maximum sales happened, and so on. So it's just formula based, or what was the average sales, and those kind of parameters or KPIs you can find out. The next is diagnostic analytics. So you can you can try to find out why did it happen in the past. The next one is predictive analytics. That is, given the past behavior, you can try to find out some possible behavior or possible pattern in future, which is predictive analytics. And in prescriptive analytics, what we do is we tell the business what we should be doing in the future for future data. So when we talk of advanced analytics, we talk of predictive analytics and prescriptive analytics. I think these are all items you would have already studied in other course, so I'll not go through this. But how do you transform data to action using analytics? So in there is you always have some data, and then you need some either some mathematical technique or any kind of technique or and human input to convert this data to action. So using descriptive analytics or diagnostic analytics or predictive analytics, you can go to a certain extent, but using prescriptive analytics, you can reduce the or eliminate the requirement of human input altogether, and you can transform directly the data to action. And in some cases, the decisions are automated, so there is no so this decision making layer is also not required. You can directly proceed to action. This slide has skipped. So how do you know if you have an optimization problem? Sometimes you might not be sure whether a given problem is more suited for solving using machine learning or more suited for solving using OR. So how do you decide which is required, whether you need OR or whether you need machine learning? So if so, these are some of the questions you need to ask to answer that question. So one is if there is any objective you need to maximize or minimize. If there is any metric we need to maximize or minimize, which could, if there is any variables which you can manipulate to achieve this objective, whether there is any restriction or limitation on the possible values of the decision variables. And these are some of the typical problems that we will be that are typically covered in optimization. So we'll go through some of these problems later on. Okay, now we'll look at the business impact of some optimization problems. So these are some companies, some examples of how different enterprises have used optimization in the past to improve their revenue or reduce their cost. So optimization is one area or one technology which can be used in all possible domains. So if you look at this list, So in this table, there are 3 columns. The first column is the name of the company, name of the enterprise. The second column is the industry to which this enterprise caters to. The third column is the business value, business impact, or the savings created by optimization. So if you look at the first column, you will see that the companies span across a wide range of industries, starting from airlines to telecom to semiconductor. And you can see the values in the third column. The values are in millions and sometimes in billions of dollars. So this is how much, this is the impact of optimization, how much optimization helps to save in terms of dollars. I've picked up one example from this slide. So Continental Airlines. Continental Airlines. So before moving to this example, so let me first give you an example of how optimization can be used for scheduling aircrafts. So what happens in airlines industry is aircrafts are limited because aircrafts are very expensive. So a company cannot have, an airlines company cannot have more than required number of aircrafts. So and there are certain number of flights it needs to schedule in a day. So how does the airlines use those aircrafts to schedule those flights? So let's say there is a flight going from Delhi to Mumbai, Mumbai to Chennai, Chennai to Kolkata, Kolkata to Delhi. So at the end of the day, the flight has to, rather the aircraft has to return to Delhi, because otherwise the aircraft crew and need to be provided accommodation in whichever city the aircraft last ends up on the day, which is an added cost for the airline. So at the end of the day, the aircraft needs to return to its base location. And then there are the different duration time windows of the different flights, and an aircraft has to reach the airport at least a particular time, let's say 30 minutes or 40 minutes before the departure of the next flight, and so on. So those are some different rules where which need to be taken in mind while allocating the flights. So that is how optimization is. So that is one of the areas where optimization is used in airlines. And what we do in crew rescheduling is whenever there are disruptions in airline schedules. For example, if a flight gets cancelled, then the passengers who are there on the cancelled flight, they need to be either provided a full refund or they need to be accommodated on another flight traveling to the same destination. So that decision is a complex one, especially when there are multiple cancellations, flight cancellations. So what the airlines need to do is to ensure that as many passengers, what the airlines needs to do is to ensure that as many passengers are accommodated on alternative flights, so that it does not need to provide a refund, and they need to be accommodated on as early as possible, so that they don't get dissatisfied with the airlines. And they need to do that at minimum cost, that is without adding too many additional flights. So this is called crew rescheduling, and this is again a very this is used massively across all the airlines. So, and this is especially useful when there are unfavorable weather conditions, when a lot of flights get cancelled, or due to crew unavailability or mechanical problems, many aircrafts are not available. So in those kind of situations, this model is used. So Continental Airlines was one of the first airlines to start or build this kind of model. And after the 9/11 terrorist attack, they were the first airlines to resume normal operations. And it is estimated that using this model, they were able to save $40 million in a single year. And of course, apart from the time savings for the passengers. Okay. Any questions, students, on this airlines problem? So the reason why we are going through some of these problems is to make you guys interested and excited that this course. I mean, optimization is not just a theoretical course. It has a lot of practical applications, and it is very heavily used in the industry. So that's why we are going through some of these examples and some of these problems, in industry problems. And in the future lectures, we'll go through. So here I'm giving just the business overview, and in the future lectures, we'll go through the formulation of some of these real life problems. Okay. So after we solve a problem, we need to rather before solving a problem, before we start doing any optimization project, we need to estimate how much business uh, benefit we can generate, can create by solving a problem, and only then we solve a problem. So let's say if my problem is very small and I am able to save only like let's say 1 lakh rupees by building a model, it does not make much sense. So because for the business, what matters is how much dollars, how many dollars you are saving, not how complex the mathematical model is or how innovative it is. So improvement. So this in this slide, I have shown two examples where we calculate the dollar savings. So the first example is of a vehicle routing problem, similar to the Amazon problem we discussed earlier. And so let's say using a model, using that vehicle routing problem, we are able to reduce the average miles by 100 per day. We are able to reduce the kilometers, the miles covered by the trucks by 100 per day. And assuming that each mile costs $2, we'll be saving $73,000 in a year. So this is the business impact that the user would be looking at to decide how useful or fruitful the project is. If I look at another example where in a factory, we use an optimization model to maximize the demand, sorry, not demand, but maximize the production, then let's say using an optimization model, we are able to produce 5,000 additional units per month. And if every unit costs $100, then we will be generating an extra revenue of $6 million using optimization. So basically, as you see here in both the examples, although the primary savings is in a different unit, but ultimately we need to convert it into dollars value. Apart from that, optimization also reduces or eliminates manual process. So earlier, maybe this was being done manually, or using Excel, or using some code, some software, or some program. And now it can be easily done using optimization. So we are eliminating manual process, and whoever was working on this manually, they can be deployed, or they can be working on some other stuff. So we are also saving headcount in the process, and we are also automating the process. And sometimes, so in both examples, I have shown the exact value, for example, 105,000, but it's not necessary that the savings will always be exact numbers. It can have a certain range as well. Okay. Now, one of the sensitive topics here is sometimes using optimization, we are able to, let's say in a factory, there are multiple machines and multiple processes and products, and they are not, the people are not being used optimally. And that is, we have more people than required. And, let's say everyone is working at 60% capacity. So that is suboptimal. So sometimes a model can suggest that we eliminate some of the workforce by using them more productively. So that is a little bit of sensitive topic, because we are, we cannot tell the business that the objective of the model is minimizing headcount. So we say that in a different way. We say that we are increasing the headcount, improving the headcount utilization. Okay, okay. Now these are some again practical examples of how much savings optimization was able to generate. So, okay, before this, okay, first let me come to this one. So these are some of the main categories of optimization problems. So optimization problems are can be divided into classical mathematical programming, which has an objective function, a maximization or minimization objective function, and constraints, as we saw earlier. Or it could be constraint programming. So constraint programming is a problem where you don't have an objective function, you have only constraints. For example, Sudoku could be one example where you have to ensure that every row and column has a digit only once, but there is no objective. So constraint programming is another area, but it does not fall under classical mathematical programming. And then math modeling could be further subdivided into deterministic programming or stochastic programming. So deterministic programming is where you know the input data with certainty, and stochastic programming is where you do not know the input data with certainty. For example, if you are running an optimization model for a factory where you do not know the demand, where you are running the model for the next 6 months, and you would not know the next 6 months demand with certainty, you might have some forecasted demand. So that would fall under, if you want to use that forecasted demand, as you can also use that as a stochastic optimization. You can also formulate that as a stochastic optimization problem. That is what stochastic programming is. And then based on the nature of the variables, we could further divide the problem into linear programming or integer programming. So linear programming is when all the variables are continuous in nature, and integer programming is when some of the variables, at least one variable, is integer. And then integer could be of two types. One is binary, that is the variables could be taking 0 or 1 value, could have the value 0 or 1, or integer programming where the variables could have any values apart from 0 and 1 also. So integer programming is required where the variables are cannot be for continuous nature. For example, in an automobile factory, the number of cars that we produce in a day, let's say if it's in dozens or hundreds, you cannot have like 5.7 cars. You can have either 5 or 6 cars. So then that is an example of integer programming. And binary programming is where the decision variables are on off in nature. For example, whether to operate a factory on a particular day or not. So either you operate the factory or you don't operate the factory. That is that for that kind of decision you need a binary variable. And you can also have a problem which has a mix of integer and continuous variables. So in that case, we call it mixed integer linear programming. And when the objective function and constraints are both, all of them are linear in nature, we call it linear programming. And when the objective function or the constraints or both of them are nonlinear in nature, then we call it nonlinear programming. So nonlinear programming could be very basic form of nonlinear programming could be quadratic programming, and then we could have higher orders of a variable, or we could have like trigonometric functions and all those things, logarithmic, exponential, and all those. So those are all nonlinear programming problems. And in a nonlinear programming problem, if you have all the constraints are linear in nature, but the objective is nonlinear, that is the simplest version. And if the constraints are nonlinear in nature, that is a bit more complex. And if both objective function and constraints are nonlinear, then that is the most complex version. And in the industry, we generally try to avoid solving nonlinear programming problems because of multiple reasons. For example, mathematical complexity, and many of the solvers are not able to handle nonlinear programming problems. And the other main reason is we are in a nonlinear programming problem, we are not sure if we have reached the global optima or we are at the local optima. So that is why generally we try to avoid nonlinear programming. So if a problem has some requirements which are nonlinear in nature, we try to convert that into its linear form. We try to linearize that. Okay. Any questions on the slide? Okay. Am I audible? Are you guys able to follow me?
Yes, sir.
Yes, sir.
Okay. Okay. So let me know if I'm going a bit fast. So this is one. So stochastic programming is one area where OR can be used in conjunction with machine learning. So from machine learning, we can get the forecasted data, and that forecasted data can be used to optimize further. Okay. So these are some of the these are some business problems which we typically solve in optimize. Some of the business problems typically solve in optimization. For example, portfolio optimization is used in the banking industry. That is, if you have multiple invest multiple options to invest, then and these different options have different risk and different return, then where should you invest so that you are able to minimize your risk and maximize the return? That is portfolio optimization. And then shortest path problem is something we already discussed. And then nurse scheduling is when you have different in a hospital, if you have different different patients and different nurse, and you have limited number of nurses, then how do you schedule those nurses to the different patients? So that is a nurse scheduling problem. And supply chain optimization. Then these are then the generic problem of this would be these things. And then these could be modeled using linear programming or integer programming, mixed integer programming, or constraint programming, what we already discussed in the last slide. And then in terms of algorithms, so these are some of the algorithms which are used to solve these kind of these kind of problems. And we'll go through some of these algorithms in the next slide and next lecture. Okay, in terms of, let me first go to this one. Okay. So I think all of you have, or some of you have booked flights, and you have seen that as you book flights closer to the flight departure date, in general, the price increases, right? So again, there is a lot of optimization and analytics which goes behind that. So what happens is, so this is an area where optimization and machine learning are used in conjunction with each other. So in this example, what you see is there are 3 flights of an aircraft of an airlines at 5 p.m., 7 p.m., and 9 p.m. And the blue bar is the number of filled seats, and the white bar is the number of unfilled seats. And in the 9 p.m. flight, there is around almost 40% seats are unsold. So what the airlines can do to reduce this, to sell some more seats, is it can offer a discount. So that and in this example, what we see is that after it offers 50% discount, major chunk of seats get sold, right? So this is an area where so this kind of problem is, as you know, it's called dynamic pricing, and it's also called revenue management. That is determining the right price to the right, or not determining, but offering the right price to the right customer at the right time. So this is an area. So in this case, how do we decide when to offer a discount or when to increase the price? We need to look at the factors that we need to look at are how many days are remaining for departure of the flight, how many, what is the time of the year. So for example, if it is festival season, we know that the seats will anyways get sold during Diwali. What is the price the competitor is offering, and what is the how many seats are unsold. So these are some of the factors we need to look at while determining when to increase the price or decrease the price, and by how much we should be increasing or decreasing. So this kind of problem is called fixed capacity perishable inventory. That means the number of seats in a flight are unsold. It's fixed. And perishable inventory, because once the flight takes off at 9 p.m., if you cannot do anything about the unsold seats. Unlike other industries like, let's say, retail, where if you are not able to sell all your inventory today, you can always sell them tomorrow or day after tomorrow if it's not perishable. So that's why it's called perishable inventory. So let me ask you a question. So you might have seen that when you're okay, I'm assuming that all of you or some of you have been on a flight earlier.
Yes.
Okay. So you might have seen that there are some seats which are unoccupied. If it's not, let's say Diwali or something like that. In general, there will be some unsold seats, right? So the question is, let's say on the day of departure, the airlines company sees that, let's say 5% seats are unsold, right? So why can't it? And let's say it's the normal price is 5,000, 6,000 in that range, and why can't the airlines offer those 10% unsold seats at let's say 1,000 rupees, right? It's better than uh, being totally losing out the money, right? Why doesn't it offer at a very low price, like 1,000 rupees?
I think certain customers who bought at higher price will be unsatisfied, or they can cancel their ticket and buy at lower price at that point.
But cancellation charge is also very high, right? It's like 2,200 rupees, I guess.
Yeah, it's true. It's true.
Anyone else or any other answer?
Maybe customers would wait for the last moment to buy the tickets.
Right. Yeah. So then what will happen is always the customers will wait for the last minute to buy the ticket, which is not a good practice. So that's why the airlines will never do that. They will reduce the price, but not to a very low extent. Yeah. That's a correct answer. So yeah. So in this example, as we discussed, as you move towards the departure of the flight, the price increases in gradually, but 1 month before it sometimes decreases, and then it again increases. Okay. So any questions on this example? Okay. Okay, and I think COVID-19. Now let's look at. We have only 5 minutes left, right? So. Okay, so let's look at some of the stages in optimization project. What are the steps or stages in optimization project? So first, we need to read the data. That is, the data could be available in SQL or Excel or any other flat file, and we need to read the data from those files, and then we need to do some data massaging, and then we do the math formulation. So as part of the math formulation, we will be we need to create identify the sets, the variables, the objective function, and the constraints, and then we solve the mathematical model. And once we get the solution from the mathematical model, the okay, so let me ask you a question. So when it comes to, so who will solve the mathematical model? I mean, how is it solved? Would you be solving it yourself, or someone
The
else would be
program.
solving? Yeah, right. So there are different optimization solvers available, which will be solving the mathematical model. So your role is just to build define the objective function, the constraints, the problem, and then pass it on to the optimization solver, which will solve the problem and give you the solution. and then you need to write the solution to the to database or to flat file, Excel, wherever you want to. And these solvers will use different techniques like simplex method, interior point method, etc., to solve the problem, which we'll see later. And this so the math formulation is something which you can do mentally. You can write it on a paper, you can write on a computer, and then after you are happy with the formulation, you can, as you're satisfied with the formulation, then you can write the code for that in any language, which is of any language of your choice, like Python, any object-oriented programming language, or Python, anywhere, and then you need to pass it on to the solver. Okay, and these are some of the steps in an optimization project. First is, so what we saw earlier in the earlier slide, that is the core, the model part, but that is just one part of the project. The other part of the project is understanding the problem from the business, designing, that is requirement understanding. Then we design the mathematical model, which you already saw in the previous slide. And after you get the model output, you also need to test the model to make sure that it is meeting all the objectives, it is running, it is not taking too much time, and those kind of things. And then you need to validate the output. And after that, you need to after that is the implementation part. And sometimes along with the model, there would also be a user interface or database, where the model data would a database from where the model would read the data, and the database, and maybe it will write the data output to the same database. So we need to ensure that the data is synchronized, and sometimes there might be a user interface also. But by the way, do you guys have a course on database also as part of your degree? SQL or anything like that?
Yes,
Just
sir.
curious. Okay. So then you have some idea. So yeah, so there would be, so in terms of the role and responsibility of the OR modeler, it is only the right side portion. For the left side portion, there would be in any organization, there would be a separate software team who would be taking care of the UI and the database. But you need to make sure that the database, the numbers are synchronized with the model output. And after the implementation of the model, there would be post-production support. So you might have to, there might be some bugs or some issues, or the user might want to add more functionalities. So those kind of things. So this is an example where, we spoke of business requirements in the earlier slide. So this is a classical example of how users can sometimes give very vague requirements. So the user can, if the user tells you something like, we want to minimize costs and downtime at our factories. All of you understand what is downtime? So downtime is basically the time for which during which the factory is not up. So this is a very vague problem statement. So it should be more. So you can ask a question like, how do you compare a solution with 1 hour downtime? So that means if the downtime is more, then my cost might be low. But if I want to restrict my downtime to a really low number, the cost will be high. So how much high downtime is acceptable to the business is what we need to check. So the user should provide inputs should provide very specific inputs, like we want the downtime to be less than 1 hour if possible, but and otherwise want to minimize the cost. Or it can be something like we can allow up to 10 hours downtime if it saves more than 1,000 units per hour. Okay, so I think we can stop here. So any questions for today? Okay, so if not, then we'll meet on Monday again.
Sir,
Can you
Yeah.
elaborate more on the kind of assignments you're going to give, like the use cases of it?
Yes. So maybe I can briefly speak about one assignment. So let's say, and it might make you guys more interested. So let's say, I think all of you see cricket, right? All of you love cricket, right? So in IPL, let's say there are 10 teams which are participating in IPL, and it's a round robin. In the round robin, every team will play against the other team. Let's say one home match and one away match. So and then there is a certain duration during which the tournament should happen. So let's say between in a span of 60 days. So within that 60 days, there should be, every team should be playing against other team 2 matches. So 10, if there are 10 teams, then there will be 10 C2 matches. And now, how do you schedule the matches so that you are able to maximize the viewership? So what is the okay? So now let me ask you, what is the objective of the IPL organizing committee?
Maximize the revenue,
Okay, and how does it how would it maximize the revenue? What are the
maximum
revenues?
sales, sale
And
of
how?
tickets.
Okay, sale of tickets is at the stadium, right?
Yeah.
Apart from that,
Ensuring more watch hours.
sorry, ensuring more.
Watch hours.
Right. So it is also shown on OTT or TV or whatever. So it needs to be shown at a the matches should be shown at a time when more people are able to view. So the more interesting matches should happen on a weekend when more people can view. Right. That should be one of the objectives. Right. So how would you schedule the matches so that you are able to the more interesting matches happen on a premium slot? So let's say on a Saturday or weekend evening, and the more interesting matches happen in the bigger stadium, so that, as you said, more tickets get sold. So those are some of the objectives. And but what can be some of the constraints? The constraint would be that it should not happen that, let's say, one team is playing, one team has to play with another team 2 matches, right? So one team will be playing 18 matches. So it should not happen that one team is playing 5 matches on back to back 5 days, and then 2 week gap, and then again it plays a match. It should So the matches should be kind of spread out across the duration of the tournament. And sorry, the matches of a team should be spread out across the duration of a tournament. And also a team should not be, if a team is playing, since a team would be playing 9 home matches and 9 away matches, the home matches and away matches should be kind of spread. So it should not happen that a team is playing 5 home matches in one go, then 5 away matches. It should happen that way. That is also unfair, right? So those are some of the objectives you have to keep in mind while scheduling the matches. So the assignment that would be given to you is, how do you come up with you have to build a mathematical model so that which will determine the best allocation of matches on days and to teams. So basically, to find which team will play against which team on which day, uh, at which venue. So let's say team X will play with team Y on 20th January at venue X at, let's say, Mumbai, right? So that will be the output of the model. So you need to build a mathematical model which will come up with that solution. Did that make sense?
Yeah, thank you, sir.
Yeah, and yeah, of course we'll discuss in more details when we go to the assignment. But this is so we'll speak about very interesting examples, such as this. Oh, by the way, I can give you one take-home assignment. I mean, not assignment, but one food for thought. So, all of you know about Tinder, right? So you can think about, or you can read up on Google or whatever. You can tell me about how operations research is used in Tinder, and we can discuss that in Monday's class. Okay. Any other question? Or if any of you has already have some ideas, you can tell me now also.
Sir, when you were talking about the downtime, what was the
Mhm.
constraint and the objective problem you were trying to solve?
Yeah, so there are two aspects there. One is downtime, and one is cost. So what happens is when you have low downtime, low, you might have to spend a lot of money. But if you are allowing the downtime to go to a certain level, then you don't need to spend that much money. So it's similar to, let me give a simple example. So let's say when you're ordering anything in, let's say, Flipkart or Amazon, you will be seeing an ETA, right? Let's say, 5 days, 10 days, whatever. So let's say Flipkart wants to keep all the customers very happy, and it wants to make sure that you get the all the customers get get the item within one day, right? Then it has to keep all the inventory at all the cities, right? Which is not practical, because then it has to have a large storage capacity, and it has to buy a lot of inventory. Right, so similar to that. So how would it keep the inventory in at different warehouses in such a way that we are able to send to the customer in a reasonable time and without incurring too much cost? So it's similar to that. I mean, basically the example I gave you of Flipkart is because it's probably something you will find it easier to relate to.
Sir, how do we find out what time is reasonable?
Yeah, so that there are two aspects there. One is the user needs to tell you that, okay, beyond, let's say if I go back to this downtime and cost example, then the user needs to tell you that, okay, beyond, I cannot go beyond 10 hours downtime at any cost. That's a hard constraint. And so, okay, so in optimization there is something called hard and soft constraint, so we'll come to that. But so the user will tell you that I cannot go beyond 10 hours at any cost, and obviously they would like 0 hours downtime, but that will obviously have a high cost. So you need to write a constraint in the model that downtime will be, and whatever the variable is, less than equal to 10 hours. And then you need to minimize the downtime in your objective function, so that you are able to and also you need to minimize both downtime and cost, so that the model gives priority to both of them. And you have to put a constraint on minimizing on that downtime will not be more than 10 hours, downtime less than equal to 10 hours.
Yeah, right. Thanks.
Yeah. And how much coefficient you need to give to the objectives of downtime and cost, that is that the business needs to tell you, which is high priority for them. Okay. Any other question? I hope you found you found this lecture first class at least a bit interesting, or was it very boring? Just need some feedback.
It was nice.
Okay. 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 Any other question? Okay. If not, then we'll end here. I'll share the link for Monday's class. Monday also we'll have that is 13th January. We'll have this class at the same time, 3:30. I'll share the link in Moodle, and you can meanwhile think about how OR is used by Tinder to solve their problem, and we can discuss that on Monday. Okay. Okay. Then thanks everyone. Have a great weekend. Bye.